Okay, we're going to close this section on Chi-Square goodness of fit tests by doing this last example on landline surveys. It says, according to the 2000 census, of all U.S. residents aged 20 and older, 19.1% are in their 20s, 12.5% are in their 30s, 21.1% are in their 40s, 15.5% in their 50s, and 22.8% are 60 or older. The following table gives the age distribution for a sample of U.S. residents aged 20 and older. Members of the sample were chosen by randomly dialing landline telephone numbers. Okay, so you can see what we're given here is there was a total of 1,048 who participated in this survey. That's important when we go back and we reference these different percentages when we're trying to get what our expected counts are. I'm going to go ahead and label this count column as the observed counts. And I'm going to create a column over here for our expected counts. And we're simply going to be taking each of these percentages, shifting the decimal point 2 places to the left, and multiplying what that percent out of 1,048 would be. Those would be our expected counts. Please keep in mind when you're doing this, you should never round the answer. So for example, to get the expected number of people out of this 1,048 who are between the ages of 20 and 29, I would need to take 19.1% of 1,048. That ends up being 200.168. And I'm going to do that with each of the percentages, and I'm going to fill in these expected counts here. Okay, so I get each of these expected counts. Again, not rounding these. I'm going to read on. It says, do these data provide convincing evidence, so I'm definitely running a significance test here, that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents. Okay, this is what the age distribution is that's being claimed here. Okay, so we're going to go ahead and state our null hypothesis. This is that the age distribution of people who answer landline telephone surveys is the same as the age distribution of all U.S. residents. Okay, so we're essentially saying that if we were to call, this is the percentages that we would expect to have each of those ages answer the phone. And then our alternative hypothesis is that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents. Okay, this is also where we're going to state the alpha level. Okay, the alpha level, we're going to use a 5% significance level since one is not stated for us. Okay, we're going to move on to our assumptions. Okay, these are our 3 conditions. 3 conditions are random, 10%, and the large counts condition. Okay, so we'll need to state some evidence for each of these 3 things here. Okay, I'm going to just make a remark here that the data was collected randomly. Okay, in terms of the 10% condition, our sample size was that 1,048. We need to make some type of a statement that we believe that 10,480 would definitely be less than all U.S. residents who are 20 years or older. Okay, large counts condition. Remember, this is a little bit different for the chi-square test. all the expected counts that you have calculated need to be greater than 5. So we need to make a remark. The expected counts are greater than 5. Okay, they need to be greater than 5. Okay, and we can see what those are right up above there. Okay, we're going to name the test. The test is the Chi-Square Goodness of Fit test. Okay, and then we learned in the previous video how to find the test statistic. That's the value of chi-squared. Okay, always want to report the degrees of freedom, and how to obtain the p-value by using the goodness of fit test on the calculator. Now, if you're going to do that, you first have to have inputted all of your observed counts into L1 and all of the expected counts into L2. So you would want to pause this video and put this data in L1 and this data in L2. You would then press the Stat button, bump over to the Test menu. Older calculators, I don't know that they have the chi-square goodness of fit test on them. If that is true for you, hopefully at this point I have provided you with a program for that. You are permitted to have a program for the chi-square goodness of fit test if your calculator did not come with that on it. For me, when I press Stat Test, mine is option D all the way at the bottom. Confirm that L1 is where your observed counts are, and L2 is where your expected counts are. For this problem, remember the degrees of freedom is always one less than the number of categories. We have 5 age categories here, so our degrees of freedom should be 4. We want to report that. We're going to go on down to calculate, and then we can report the chi-square test statistic. You can round it to 2 places is fine. Be very careful. The p-value that you are provided with, if you look all the way to the right, you see that E with a -10. That means this is in scientific notation. If you were to move that decimal point 10 places to the left, this number is so tiny, it is virtually 0. Okay, now we're ready to go ahead and compare our p-value to our alpha level. Since our p-value of essentially 0 is less than our alpha level of 0.05, we are going to choose to reject the null hypothesis. Okay, that means that we have the convincing evidence here that and this is where we fill in our alternative hypothesis. We're essentially just copying the alternative hypothesis in this place here, that the age distribution of people who answer landline telephones is, telephone surveys is not the same as the age distribution of all U.S. residents. Okay, and that brings this section to a